Okay, hi everyone, and welcome to another section of notes. Today we're still working through Target 23, and this is the part 3 section of notes for Target 23. And so just like part 1 and part 2, we're going to kind of do the same thing we've been doing. Again, learning target, still Target 23, so we're still finding perimeter and area of 2D figures, but today we're working with trapezoids and kites. And so let's get right to it. All right. So trapezoids, what we'll start with. Trapezoid area formula is this. Area of a trapezoid equals, and this is in parentheses, base 1 plus base 2. So we add our two bases together, and then we times whatever we get when we add them together by our height, and then we divide the whole thing by 2. And so yeah, it's actually kind of a big formula, right? And so there's a little bit we got to do here to work through getting the components that we need that'll fit in this formula. First of all, remember what a trapezoid is. A trapezoid is a figure with exactly one pair of parallel sides. So in the way that this trapezoid is drawn, the top and the bottom are parallel to each other, but you'll notice the left and the right are not. The left and the right are both like slanted inwards, so they are clearly not going the same direction, so not parallel. And so that's crucial to have this discussion, and the reason is the parallel sides are your bases. So that one's a base, and this one's a base. Now, it doesn't matter which one's 1 or 2, but one of those numbers goes into B1, the other number goes into B2. And then our height, you actually can't see it in this picture, and you'll understand why in just a second. Our height works just like the heights have been working for like triangles, parallelograms, and the other shapes. Our height always has to make a 90-degree angle with our base. And so you'll notice neither of these two sides, right, are making 90-degree angles with any of the bases. And so our height is one of these imaginary lines that we drop down from one of the corners, and it hits the other base and creates a 90-degree angle. And again, that is what we consider our height. And so we take our two parallel sides, we add them together, we times it by our height, and then whatever we get, we divide by 2, and boom, there's our area. So let's do that down here. Now, first couple things to note. Right, in these two examples, we're finding area and perimeter. Let's start with area. The reason why we're going to start with area number 1 is we actually have all the information we need. Remember, area is base 1 plus base 2. Now we put those in parentheses, and remember, order of operations, we do that first. So we're adding our bases together first, and we're multiplying by our height, and we're dividing by 2. And so remember, your bases are the two parallel sides. So 15 and 7 would be my bases. So this will be in parentheses 15 plus 7, and then times. And then remember, your height is the side or the line that makes a 90-degree angle with one of your bases. And it's always vertical. And so we'll times this by 10, and then we'll divide by 2. Now, for now, I'll take it slow as we simplify this algebra. In the future, we'll just plug it into our calculator and we'll get a number and we'll be good to go. But again, let's work through parentheses first. That is what we need to do first in order of operations. So 15 plus 7 is going to be 22. So we'll have 22 times 10, and then we'll divide that by 2. 22 times 10 is 220. Divide that by 2. And 220 divided by 2 is 110. Now notice the quotation marks on the 10 and the 15 and the 7. So this is inches squared, 110 inches squared. So really what you just need to recognize is what are our two bases? We're adding those numbers together, and then we're going to multiply it by the height and divide by 2. Now that's for area. So I'm going to clear up this figure a little bit because we need to know perimeter, right? And so we need to know this slanted side and that slanted side because perimeter means we're going to add all the sides together. And we don't know those sides. But one thing we do know is that both of the sides, because of these markings, are going to be the same. Those markings mean they're congruent, right? And so this is actually fairly complicated. So please pay attention and we will get the lengths of those sides and then we'll move on. So what I want you to see here is, let's change colors for now. What I want you to see is this height. And what I'm going to do is I'm going to draw that height again, and I'm going to draw it from the other corner as well. And so this shape now has two heights drawn. Now here's why. From one height to the other height, that's exactly the distance as this bottom base, right? That is always 7 from one height to the other height. So even though this full base up at the top is 15, it's only 7 in between our two heights, right? Which means that what's remaining on these two parts, first of all, they have to be the same as each other, but second of all, they have to fully add up to 15, right? And so if the whole thing is 15, in between our heights, like I said right here, is 7, that means there is 8 units left between these two little slots. Now, there's 8 total. Each one of them has to be the same. So if we do 8 divided by 2, we are going to get 4 and 4, right? Now, I know that was a long discussion. Hopefully it made sense. Here's one thing I want you to be confident with. Remember, that whole top base is 15. And so we've broken up into 7 and 4 and 4. 4 plus 7 is 11, plus another 4 is 15. So you can see that we have definitely broken it up into 3 different numbers that still add up to a total of 15. And so I think we've got what we need here. Again, we drew 2 heights. The reason we did this was because then we can start splitting up that longer top base. In between the heights is 7, just like the bottom base. So then on the outsides, each have to be 4, because 4 plus 7 plus 4 is going to add up to 15. Now, as always, our goal here was to make a triangle. And so I'm going to draw this triangle down here now. I have my height is 10. I have this slit at the top is 4. And then this side I don't know with a tick mark through it, I can call that X. And I know that my height and my base up top create a 90-degree angle, and so this is a right triangle. And so as always, like it's come down to several times, right? We are going to use a squared plus b squared equals c squared to figure out this X. We need to know what c is. It's always across from the 90. And so our X is our c. So we can do 4 squared plus 10 squared equals x squared to find the perimeter. And 4 squared is 16, 10 squared is 100, so together that's 116 equals x squared, and then we will square root both sides. And so we find that that slanted side is going to be 10.8, roughly 10.8. And so I want to come back up to our original picture here, clean it up a little bit. Remember, all the work I just did was me figuring out that that side there is 10.8, right? But then secondly, I know because of this tick mark and this tick mark, both sides are the same, so this has to be 10.8 as well. And then I already knew this bottom base was 7. And then even though I split up the top, the full top side, right, is 15. And so my perimeter is going to equal 7 plus 10.8 plus 15 plus 10.8. And when we add all 4 of those numbers together, we're going to get a total perimeter of 43.5 inches. Now, that was quite the process. So soak it in, maybe rewatch the video, practice a little bit, and please answer or ask me some questions as they arise. Now, let's go to number 2, another trapezoid. All right, first thing, here's a little typo here. This thing is really the 90-degree box. It just happens to be floating in the middle of this shape. I don't know why. And so kind of ignore that box and just remind yourself that it's telling us that that's a 90-degree angle. Okay, that's a 90-degree angle. All right, now there's quite a bit that we have to do here. We know our 2 bases, but we don't know our height. Now remember, our height makes a 90-degree angle with our bases. So this side over here is our height, although it doesn't help us that much just labeling it like that. But I want you to take a look at the left side of this trapezoid, and you see a bunch of imaginary lines over here. So many imaginary lines, For instance, that it's actually creating a triangle on the outside of our shape. And I want you to notice that this up and down imaginary line on the left is the same line, at least the same size as the line on the right side of our shape. And so this has to be our height on this side as well. And that's a good thing, right? Because once we get into this triangle that has degree measures in it, we can use sine, cosine, and tangent to try to find these missing things. Now, we're going to need that height to find our area. We're also going to need it to find the perimeter because, again, it is the length of this side on the right side. Now, in order for us to find our perimeter, we also need this slanted side over here. And so I'm just going to call that X for now, but we're going to need to figure that out. And additionally, we do need a number in this triangle for us to use the triangle in a sine, cosine, and tangent way. Right now, I don't have any numbers. I know the left side's H, I know the slanted side is X, and I don't know anything about this bottom side. And without a number, I can't set up my sine, cosine, tangent ratios properly. But here's what I want you to see. Let's change the color. From way over here, all the way over here, right? That's 15. And then down here, so it stands to reason that from this corner all the way to that imaginary line is also 15. So if this whole thing is 15, but from here to here is only 12, then if I do 15 minus 12, which is 3, that tells me how much is left over on the bottom of this imaginary triangle, right? And so what I would like to do now is, let's pretend we're working with this triangle down here. And let's solve for H and X. I know this is my height. I know that's a 90-degree angle. I just figured out that the bottom part is 3. I know this angle in this corner is 60, and this slanted side is X. And so we're going to get ready to use SOHCAHTOA, right? SOHCAHTOA. And so every time we pick an angle, we got to label opposite, which is across from that angle, hypotenuse, which is across from our 90, and then adjacent, which connects to our angle. And so remember, we always have to use this 3 since it's a number we know. And so let's use the 3, for example, and then let's find H right now, the 3 and H. So if we want to find H, we have to work with opposite and adjacent, right? Opposite and adjacent. That comes from TOA. Tangent is opposite over adjacent. So tangent of 60 is going to equal opposite over adjacent, so H over 3. And then we'll times both sides by 3. So our fraction can cancel, leaving us with H on the right, which is what we want, and that'll be equal to 3 times the tangent of 60. And so when we type that into our calculator, we will know what our height is. Let's do that real quick. Real quick reminder, be in degree mode. To check, click the mode button. Ooh, click the mode button. 3 rows down, you'll see radian and degree. We want degree highlighted. If it's not, scroll down, highlight it, and hit enter on it. All right, and so since I'm in degree mode, I'll just quit, and we'll type in 3 times tangent of 60. Close the parentheses, hit enter, and boom, there it is, roughly 5.2. So our height is 5.2. Now, let's keep working with this triangle, because not only did we need our height, but we needed X as well, right? And so if we want to find X, we're going to need to use 3 and X. Now, X is our hypotenuse, 3 is adjacent. So we need adjacent and hypotenuse. That is the part. And so for us to find X, we are going to use the cosine. And so let's set this up, and then that'll be about it here. And so again, the cosine of 60, it's adjacent on top of hypotenuse. So this time 3 over X, right? And we will solve for X as soon as we start the next video. Thank you very much.